Okay, so now we are into the next part of our video. Now we have two kind of design. One is top down and what's the second one is bottom up. In top down design, you start with a very high level structure of the system. Then you then gradually work down towards detailed decisions about low level constructs. For example, you are want to build a particular system, right? Now you will particularly deal with high level issues first, right? Then you're going to divide it. Then second level issue, third level issue, fourth level issue. So now, for example, what is a software architecture? Then what is kind of database? After that, how queries will be placed? Now, what are the classes? What are the different kind of methods or something. So what you're going to do is, whenever you're going to use top level decision, first of all you will have higher level decisions. After that you will have a detailed decision, and after that you will have a individual algorithm or individual method. This is how you're going to proceed. So now first you have to discuss very high level structure, then you continuously going to gradually deepen that, right? After that, finally what you have arrived at, what format of particular data item, what are the individual algorithm used. So this is how top down approach works. Now its inverse approach is bottom up. In bottom up, what you are going to do is you are going to make a decision from low level. The benefit of using bottom up approach is that you can have a reusable component. For example, you start with some kind of, let's say, small functionality. You can reuse it any number of time, any number of projects, right? So that will be more easier. Now in reality, what we do is we take a combination of top down and bottom up both approaches. So whenever you want to give a good structure to your project, you should use top down approach. Whenever you want to make full use of reusability, you should take bottom up approach, right? So these are the major two difference between top down and bottom up approach. Now you have a different aspect of design. Now designing can be of many types, right? Few things are mentioned over here, few things are not mentioned over here, but I tell you the all. For example, different aspect of design. The very first one is architecture design. In architecture design, what you are going to do is you are going to divide a software into subsystem, or a system into subsystem, right? Then further into component, as well as the process of deciding how these will be connected and how they will interact, including determining their interfaces as well. Correct. So it's very easy, right? So how they will be connected, how they will interact, how their interfaces will work. All these decisions are done in architecture design. After that comes class design. In class design, what you are going to do is you're going to design various feature of classes, such as association, what are the attributes, how they are going to interact, what are the states a particular object can take, right? All these decision or features are done in class design. UI design, it's a very big topic, right? In this, there lot of things can be covered. I'll come to this later on. In algorithm design, the major thing is how you are going to compute your solution is a part of computational or algorithm design. Correct. After that, there is another kind of design called database design. In the database design, what you're going to do is you're going to design how data is persistently stored so that it may be accessed by many programs or user over an indefinite period of time, right? Whenever you want to access it, it should be available. After that, we come with protocol design. In protocol design, what we are going to do is we are going to design communication protocol. For example, the languages with which we process communication, and which other let's say we process communication with each other over the network. So these are the design. Every particular topic is let's say a book in itself, but I cannot cover all, but I'll try to cover the maximum one, right? After that, it says principle of leading good design. See, what is the principles or what are the main let's say guideline so that you will have a good design over there, right? So now, first of all, every organization wants to earn profit, right? That is a private one, especially. Correct. So now, thing is, how can what is the, let's say, overall goal of good design? Obviously, you want to earn money, right? So you should increase your profit. Now increasing the profit will be like reducing the cost or increasing the revenue, right? So for most of the organization, this is central objective, right? Now, however, there are a number of ways to reduce cost and also different ways to increase the revenue generated by software. These all are part of design. Now, also you need to ensure that we actually conform to the requirement. Thus, we have to solve customer problem. We should not go beyond that, right? After that, we need to accelerate development. Accelerate development means you should reduce short-term costs to ensure the software reaches the market soon enough to complete effectively and may be essential to meet some deadline faced by the customer. If it provides some deadline, something like that, that I need this software in within 1 month or 2 months because that's my season's days, something like that. So you can have that as well. Other than that, for good design, it should be usable, it should be efficient, it should be reliable, maintainable, reusable. All these properties must be there. But main objective is to reduce the cost and increase the revenue, right? Yeah. So now first design principle, right? So design principle says that divide and conquer. So now if you divide a problem, then it will be very easy to solve it. That's a very old saying. So now if you're trying to deal with something big at all at once, it's better to deal with series of smaller things, then you can easily solve that problem. Correct. So now what are the, let's say, many advantages of doing this, right? What are those advantages? Separate people can work on each part. Now you have many people, right? Now original development work can be done in parallel. That's the main benefit. That's why you need, let's say, less manpower to solve a particular small problem, right? And if you need a complex, you need to solve a complex problem now, you need to have more issues, you need to solve more issues, you need to have more kind of, let's say, experienced people, right? Something like that. Now another benefit is an individual software engineer can specialize. For example, you're doing something on UI, right? That's your component. So you can become expert of that. Now, it is possible for someone to know everything about a small part of the system, but it is not possible to know everything about the entire system. You cannot be expert of database, network, programming language, UI all at once. I know a full stack developer are there, but still they would have few parts which are not being done by them. Correct. So that's why this is there. Now third is each individual component is smaller and therefore it is very easy to understand. That's a very true thing, right? After that, when one parts need to be replaced, right, or changed, then in that case this can be done without having to replace the other parts, or you don't need to change most of the part of the system. So this is the main reason of using divide and conquer technique. Now other ways is other benefit is that there are many ways to divide a particular system. Those ways are a distributed system divided up into clients and server. You can do like this. Now a system can be divided into subsystem. A system can be divided into one or more packages. And now further a package can be divided into classes. A classes can be divided into more methods. So these are the principles through which you can divide and conquer. That means you can divide and you can solve the problem easily. So let's stop at this point. I would like to cover the next principle, inclusion of design principle of 2, that is increase cohesion within the module. And after that, I'll decrease the coupling within other module. Got it? So that's all for now.